Hey guys, welcome back. Today we're going to be talking about hypothesis testing. This time with means. Last week we looked at the hypothesis test. We did a couple of examples with proportions. So we're going to be talking about hypothesis testing with the mean. And you'll notice that I have two tests up here. One is a t-test, one is a z-test. So this is very similar to what we did with the confidence intervals, where we're going to have two possibilities that happen with the mean based on what information we have. So the first example that we're going to see today is going to be what's called a t-test. And it's going to be a t-test because we don't know what the population standard deviation is. Okay, if we did know what the population standard deviation was, we would use the z-test. So let's talk about our scenario here, and we'll kind of go through it again step by step, and we'll see how this hypothesis test for a mean works. Okay, so the Mars Candy Company claims that a typical M&M weighs about 2.4 grams. This is the company claim. This is what they believe to be true about all peanut M&Ms. All right. So we suspect that the weight may be less than 2.4 grams. All right. This is our suspicion. We're not sure. But we're going to collect some data and see what happens. All right. And you might recall a while back when we were still in class that we did an experiment where we weighed a whole bunch of M&Ms together as a class and we collected all of that information. So I have that right here pulled up, and I think you guys still have access to the spreadsheet. I think I shared it with all of you guys. So you can see we weighed 660 M&Ms here, and we got a mean of 2.33 grams for a peanut M&M with a standard deviation of 0.36. So this is where our data is coming from. And if you can envision, if we were in class, I might get a different candy or something like that and let you guys actually get the scales out and weigh that stuff. So that is where the rest of this information is coming from, right? So in that experiment, we took a sample of 660 M&Ms. We found the sample mean to be 2.33, and the standard deviation is 0.36. So is there evidence that the weight might be less than 2.4 grams? That's what we're looking for evidence for at a 10% significance level. Okay, so let's go ahead and set this up. Even though we're doing a mean, the steps in the process that we learned last week is almost the exact same. We're going to start by setting up a null and an alternate hypothesis here. So I'm going to say H0, H1, or HA, whatever you prefer there. And I'm going to say that the assumption about the population is what the Mars Candy Company said, right? Our assumption is that the mean is 2.4 grams, right? So the population mean is 2.4, right? And alternatively, right, the contradiction to that would be that the mean is less than 2.4 grams, all right? This is what we're looking for evidence for, right? We go and we collect our evidence and we're trying to test whether or not the mean is actually 2.4 and trying to find evidence that would suggest that it's less than 2.4 grams, all right? So there was some confusion, I think, last week with what was a parameter and what was a statistic, and this was something that we talked about at the beginning of the semester. The parameter comes from a population, and it's usually unknown. There's an assumption about it that's usually made, usually by a company or some kind of agency. They say, hey, we assume the population mean to be this number. Right? A statistic comes from our data, whatever it is that we weigh or measure or collect. That's where the statistic comes from our sample. All right, so there's no need to hypothesize about a statistic. So make sure that when you are writing your null and your alternate hypothesis that you're using the correct symbol. All right, this should not be an X bar, it should be a mu since we're testing something about the population. All right. So let's continue on here. I left the box over here where we would have put our data because I just want you to envision like you're in class and we're doing, it's more fun than it is when you're watching a video. Like we're actually measuring candies and talking to each other and having fun. So that's where we would do this piece is we would actually go and collect our data as part of this hypothesis test. Okay. So the second step here is to make sure that we have a sampling distribution that we can use. There is a sampling distribution of the mean, but to use it, we have to have a large enough sample size, which we do, right? So our sample size is 660, and we know that the sampling distribution normalizes when the sample size is larger than 30. And so we know that we're going to be normal. All right, now the center, and this is where things started to get confusing like with the symbol. So this is the center of the distribution of means, right? So it's a sampling distribution, but based on our assumption about the population, right? The population mean has to be the same as the sampling distribution's center, okay? So we're assuming that that center is going to be at 2.4 based on what the Mars Candy Company is telling us. It's always based on the null hypothesis, right? The spread of the sampling distribution that we're using, we don't know what the population standard deviation is, and this is what forces us to use the t distribution, because what we're going to do, since we don't know what the population standard deviation is, we're going to be using the sample standard deviation as a replacement, right? And our sample standard deviation for this was 0.36. So we have to take that 0.36 and we have to divide it by the square root of the sample size, which was 660. And when I do that, what I get is the standard error for our sampling distribution, which is 0.01. All right, so we have a center of our sampling distribution and we have a typical spread for our sampling distribution, and this is what we will move forward with. Now remember, we are using the t distribution because we had to make that substitution going forward. All right. So step 3 here is to actually carry out the test now that we know what we're using. So our test statistic is a measure of how far away from the center we are with our test data. Okay, so our test data told us that we got 2.33 as our mean weight. We were supposed to get 2.4, right? So to figure out how far away we are, we simply subtract those two things. And then we divide that by what a standard error would be. So 0.014. And this will tell us how many standard deviations away from the expected center we are, right? So when I subtract these two in the top, I get negative 0.07 divided by 0.014, and you should get like 4.99. I'm just going to round that to -5. And what this tells us is we are 5 standard, right? And if you remember from the beginning of the semester, being 5 standard deviations away from anything is extremely rare. Not a lot of things get 5 standard deviations away from what we expected. So this is kind of an indicator that this is not likely to happen. We're not likely to get 2.33 as our sample mean when we're expecting to get 2.4. Okay, so then the next thing we're going to calculate is the probability of this happening. Okay, so think about your distribution. When we calculate a probability, we have a normal curve. This is our sampling distribution, okay? And we'll put it here at the center. So for any normal distribution being 5 standard deviations, since it's negative, it would be over here on the left. So I'm going to put -5 over here, right? What is the probability of being 5 standard deviations or more away? Well, it's this area under the curve here. This is what our p-value is this area. That's how we calculate that probability. And since we're using a t distribution to calculate this, we're going to use a t-CDF. And we're going to say we're going from -infinity, right, all the way to the left, up to our boundary here at -5. And then the last thing that the t-CDF wants to know is your degrees of freedom, which is always 1 less than the sample size. So that's going to be 659. Okay, so I'll bring up my calculator here and we'll run that calculation. So we'll go second distribution. And we're going to go down to where it says t-CDF, which is option 6. And I've already got my -infinity in there with the -1e99. I'll put the upper boundary as a -5. And then I tell it the degrees of freedom, which is 659. And we'll paste that and see what we get. So we got a probability of 3.68 e -7. Okay, it's a very small number, so the probability of getting 5 standard deviations away from the center is very low. Okay, so again, what this value is that we just found, right? We say the p-value is equal to 3.68 e negative 7, this is the probability of this, of getting 5 standard deviations away from what we expected, is this. Okay, this very, very small number. It is highly unlikely that we would get this with the mean being 2.4. Okay, so let's move on to the last step here. All right, this is where we make our conclusion. We have a p-value, and the way that we make our decision is by comparing the p-value to our significance level. Okay, so we say since the p-value of 3.68 e to the negative 7 is less than the significance level of 0.1, we reject the null hypothesis. Okay? So we are not going to believe that the mean is 2.4 because the probability of getting what we got from our sample data is 3.68 e to the negative 7. It is so unlikely. We cannot believe that the mean is actually 2.4. So then we write our interpretation. We say there is sufficient evidence to support the claim that the mean weight of an M&M is less than 2.4. Okay? So you have to do your comparison of the p-value to the significance level. If it's less than, you're going to reject the null hypothesis. Then you'll go on to say that there is sufficient evidence to support the claim of the contradictory statement that you started with. All right? So we want to verify this using an appropriate test from our calculator. So I want to show you how to run this test on your calculator real quick. So if we go here, we're going to hit Stat. We're going to go over to Tests. And you'll notice the very first two tests here is a z-test and a t-test. We did a t-test since we did not know the population standard deviation. So I'll hit Enter. And we're going to be entering in the stats. I'll show you an example with the data here in just a minute. But the mean, this is our assumption about the mean, right, which we said was 2.4. And then our sample mean, this is what we got from our data. We got 2.33. And then our sample standard deviation that we got was 0.36. And our sample size was 660 M&Ms. And then it wants to know what kind of a test are you doing? Are you doing a two-tail, left-tail, or right-tail test? We tested that it was less than the mean, the assumed mean. So we're going to go with the less than, which is a left-tail test, and then go down here to calculate. If you hit draw, it's going to show you the normal distribution that I drew in step 3 of the problem. It's just going to show you where the p-value is located on the normal curve, which is a nice thing to see. If you're not sure about that, the calculator will show it to you. When we hit calculate, it'll go ahead and calculate all the stuff that we just calculated by hand, right? So it gives us our test statistic here, right? Which this is our 5 standard deviations away from the middle. This is our p-value that we calculated by doing the t-CDF. This was our sample mean and our sample standard deviation and our sample size. So it gives you all the pertinent information that you need for your test. So really, when you do this, all you need is the p-value. You just have to see if that p-value is greater than or less than your significance level to make a decision about the claim. Okay, so we're just using this to verify what we just did by hand in steps 1 through 4. Okay, all right. So let's continue on. So after we do a test, typically, if we were doing this professionally, we would kind of report on what errors could possibly be made and what the probability of those errors are. So we would like to know what a type 1 error would be for this test. So we're looking at our type 1 and type 2 chart that I provided for you last week. So remember, type 1 occurs when we reject the null when the null is true. All right, so in context of this problem, a type 1 error would occur if we rejected, right? We reject the mean is 2.4 when it is. Okay, that would be what a type 1 error is in a very simple statement. So then a type 2 error would be, and I can go back to the chart here, we would fail to reject the null hypothesis when the null hypothesis is false. Okay, so we fail to reject the mean is 2.4 when it is not 2.4. Okay, so there's a type 1, that's a type 2. And then for right now, in the scope of this class, the probability of a type 1 error is something that we can easily find. And the probability of type 1 error here would be 10%, which is equal to alpha, our significance level. Okay, so the probability of making this error is 10%. Finding a way to calculate the probability of this is a little bit more complex. So you would want to continue on with your statistical studies to learn about how to find the probability of that type 2 error. All right, last thing I'm going to show you today, I'm going to show you a z-test, but I'm going to do this completely on the calculator, or at least as much of it as I can do on the calculator, so you can see how quick one of these tests can really go. All right, so let's read through the problem. It says, suppose you're doing maintenance on a fountain soda machine. One press of a button is supposed to dispense 16 ounces of soda, and it has a known standard deviation of 0.2 ounces. So notice they are telling us what the population standard deviation is here. That is your clue that you're going to use a z-test instead of a t-test. All right, we're also going to assume the population is normal, and that is probably because they have a very small sample size here. It looks like they only filled up 16 cups. So we wouldn't have a sampling distribution that we could use with only a sample size of 16 unless we knew that the population was normal. All right, so that's why they're telling us that. So I'm going to go ahead and set up a null and an alternate hypothesis because the calculator won't do that for us. We have to be able to do that part. All right, so the assumption is that the machine should dispense 16 ounces of soda. So I'm going to say the mean is equal to 16. Okay, now the alternate hypothesis, we have to kind of read the problem. Do they want us to test that it's dispensing less than or more than, or they're just not sure and they want to say that it's different than 16 ounces? So it says you run a test on the mean to see if the machine is working properly. Okay, so they didn't give us a whole lot there. They didn't say less than, they didn't say great than. They just want to know if it's working properly. So it could be working improperly if it dispenses too much soda, and it could be working improperly if it dispenses not enough. So this is going to be a two-tail test. I'm just going to simply say that the contradiction here is that it's not equal to 16. So this will be my setup for the null and alternate hypothesis here. Okay. All right. So I'm going to go ahead and grab my calculator and I'm going to start running this test and see what I can do here. So I'm going to go to stat and I'm going to go to edit and I'm going to enter in the data that they give me here into L1. Okay. I'm going to put all of that into L1. So go ahead and take a minute and do that. And once you're done, you can hit pause if you want and then click play when you're done. And then we're going to go to stat. We're going to go over to tests, and we're going to use z-test this time. That's option 1. Right? And we're going to tell it to use data this time instead of inputting our own stats. We're going to tell it to use the data. Right? And they want to know, what is your assumed population mean? Well, that's 16. And they want to know the standard deviation, which is 0.2. And it wants to know where your data is. So I told it I put my data into L1. And then it wants to know, are you doing a left tail, two tail, or a right tail test? So we're doing a two tail test. So I'm going to tell it to do that. And then I'm going to hit calculate. And it should produce everything I need there. So I can see my test statistic. I'm 2.3 standard deviations to the left. So it tells me that the machine is underfilling, but still I'm 2 standard deviations to the left. And my p-value is 0.0175. So that's really the key piece of information that I need here. So p-value is 0.0175. I'm going to compare that to my significance level. So 0.0175 is less than the 5% level of significance they want us to use. So 0.0175 less than 0.05. So in that case, we reject the null hypothesis, right? We're rejecting this, that it's 16 ounces. So I'm going to say there is sufficient evidence to support the claim that the machine is working improperly. Okay, and you could word that a little bit different. You could say support the claim that the machine is malfunctioning, that the machine is not working properly. But we're essentially trying to say that the machine is not working the way that it's supposed to. We have the evidence to support it right here. Okay, so that's a z-test and a t-test on a mean, going through the whole process, and also looking at how the calculator can help us out with this as well. All right. See you tomorrow, guys.